Hello, all. Welcome to part 2 of section 5 involving percents. We're going to start with 5.3b, solving percentage problems using proportions. This is a lot of word problems, things along those lines we're diving into. It's part of the game, right? That's what we do with mathematics. So, to start, let's talk about the parts of a percentage proportion. When I say percent, what do I mean? That's essentially what I'm getting at here. What is a percent? Well, a percent is some number divided by 100. That's how we define percent. 100 cents per cent, right? So the amount you have over your base is equivalent to the percent number over 100. This is a way to translate things that aren't divided into 100 into percents, essentially. For an example shown here, 10% of 500 is 50. What does that mean? Well, we can look at this example here. Let me pull up annotation. There we go. We can look at this example here, and we know that whatever the percentage is, that's over 100. By definition, percent is over 100. Your percent number, the top part here, is going to be, well, your percent number, the 10%. So what we're doing is essentially building up a fraction equation to try to answer the question. This guy right here is actually supposed to be the question. It's the answer as well, but it's supposed to be the question. So how do we do that? Well, if we take this basic equation shown here, we can translate it down here and fill in what we know and solve for what we don't, right? So what do I mean by that? I mean, given this information, we know we have two fractions, essentially. One of the fractions is our percent. The other fraction is the question. All percents are over 100. In this case, the question would be telling us 10% of something is something. Well, 10% would be 10%, right? 10 over 100. Now the question remains, well, again, if this was phrased as a question, 550, where would those fall into place here? Well, 10% of 500 is what? 500 is your base or your new denominator. Solving like this, where here would be the unknown, and then this would be a cross multiplication example, right? That's how percentages work. That's how this basic idea is formulated. Pretty straightforward. Once you have an understanding of this concept, it's simple math that we've been doing plenty of. And I'm going to apologize if you guys hear cats yelling at each other. They are fighting right now. I wish they wouldn't. Anyways, so let's go over an example. Identify the amount, base, and percent number. Again, why is this important? Because our equation involves those two things and 100 for definition purposes. So what is 9% of 65? What is our equation that we start out with? Our equation, the skeleton, as I like to say, of the equation, looks like this, right? This is the end result, and we just need to know where those numbers go in this particular conversation. If you start out by building your skeleton, writing down your skeleton equation, you will find the answers fall into place a lot better because you have places for them to go, right? As said before, we have a base, an amount, and a percent number. This right here is a percent number because it's the percent, right? So the 9 would go up here. Then we need to look at the 65. We need to say, is this a base or is this a amount? That's a tough one, right? So again, we have to look at this as a sentence, as an English sentence. How would we read this as an English sentence? 65. 9% of 65. Okay, is that the smaller number or the bigger number? 9% is a very small percent, right? 9% is, 9 cents doesn't buy you anything out of 100 cents, right? So 9% of 65, does that read as the answer should be larger than 65 or less than 65? I would read that as the answer would be less than 65. So we know this 9 is smaller than this 100, meaning the answer or your amount is going to be smaller than your base. Solve for x up there. That would be the idea going forward here. And that's exactly what they show here, where you need to solve for these individual components. So again, we can move on. 24 is what percent of 144? What goes where? Well, regardless of what goes where, if we draw a little skeleton, we can fill in what we know. Notice there is no percent sign anywhere in the question. So that must mean the percent sign is what we're solving for. Well, that makes sense, right? This guy is what we're solving for. Now we got to look at this. 24 is what percent of 144? Which of those is the amount? Which of those is the base? Which of those is the top? Which of those is the bottom? Tough one, right? Again, we have to look at the question as a sentence and try to solve what we mean. Is this going to be as our two examples? It's a weird looking E. Our two examples of answers would be 24 over 144 or 144 over 24. Those are our two options here. Pretend that's a 4. Those are our two options here. Which one makes the most sense? 24 is what percent of 144? You got to say it to yourself. You got to think, what would my answer look like? Am I talking about a small percentage, as in less than 100, or a large percentage, as in greater than 100? In this example, I read that as 24 is the smaller of the numbers. 24 is less than 144. 24 would be a smaller percent. So I would probably end up with something like this. That's how I read the equation. It's important to know how to read the equations, right? We cover this stuff all the time in this class. It's important to know how to read these equations. So, actually, there's a little mouse feature there. Can I do that? Hey, I can. Fantastic. I don't have to erase that little doodad. So we know how to write this. And as we look at the answers here, we see that A, we did it correctly. Kudos to us. Go team. Now we get, as I was saying at this point, to the solving. How do we solve these individual questions? Well, said this already, right? This is cross multiplication. This is a very simple math equation. The problem is how to set it up. What is 9% of 65? Well, let us build the skeleton of the equation. We already start out with 100. The 9 as a percent, so the 9 would go here on top, and then where's the 65 go? Well, you need to know if the 65 is your amount or your base, and you read the sentence and try to figure out which is the correct answer to that, right? Best way to tell is, well, what is 9% of 65? 9% of something is a small amount, so the 65 would probably go in the denominator because you want your numerator to be the other side, and then you, as we've talked about plenty of times, once you have this stuff made, you cross multiply, and a little cross multiply, set up your equation, solve your equation, divide by 100 because division is the opposite of multiplication. And there you go, 5.85. And now what you do is if you divide 5.85 by 65, you'll get 0.09 because 0.09 is 9%. Fantastic. Again, if I run too fast, if you have a question, let me know. I'd prefer a hand raise, but if you're on a phone or something where it's difficult, you want to talk, go ahead. Like, chat is open in case you need to talk in the chat. Do whatever you need to do to help you get across. I also, of course, will talk in the comment section. Again, we can continue this policy here. We have the basic structure. We have the basic skeleton of our equation. All we need to do is figure out what goes where. In this case, 36 is 6% of what? We have a percent sign, so we know the 6 goes here. And then we have to read the equation, figure out the English definition of what's going on here. 36 is 6% of what? Is 6% of, to me, sounds like the top number, the numerator, the, what do they call it here? The amount, right? The A section here. 6% is less than 100%. So the number on the top, by definition, the numerator needs to be smaller than the denominator. Cool. So when we set this guy up, we then cross multiply, my go-to, run through the math that is something we know how to do, divide out what we need. We find out that the base is 600. 600 is way bigger than 36. So our answer fits with what we thought it would be. Hey, go team. And then, as I suggest, always draw your little alligator teeth if you get the opportunity. Eating the bigger piece. Fantastic. Right? This is, again, I've been stressing this throughout the class. These math problems are math we know how to do in ways we're not familiar with. That's the whole intent here. Y'all know how to multiply. Y'all know how to divide. But how do you set up the question so it gets to where that's the obvious thing to do? That's the key. That's the ticket. I prefer my little drawings than that. Right? Going on and on and on and on and on. What do we have here? What do we know? What goes where? We have our skeleton equation showed up here. We notice that there is no percent, so percent must be what we're solving for, right? They use P as the variable. You can use X or N or whatever you want to do. It's up to you, right? And then 24 is what percent of 144? That is purely, I keep saying it because it's true, that is purely I need to know how to translate the English into math to know if the 24 is the A and the 144 is the B, or the numerator or the denominator if you prefer. Because once this basic equation right here is set up, the math is easy to solve. The problem is setting up the equation. If you flip these two numbers around by accident, you got a wrong equation, right? You're doing your math incorrectly. Sad days. We don't want that. So run through it, figure out what it is. Also noteworthy here, the answer is not necessarily a straight integer, right? 16.6 repeating or 16 2/3. Both of these are acceptable answers. They both represent the same thing. If you want to turn this guy into a improper fraction, you can, as long as your answer is correct, right? Because these all these numbers represent the same thing. All right, so that was fun. We all had a fantastic time. Let's move on to solving applied percent problems. i.e., let's do the word problems. I know, we all hate it. I get it. But that's how the world works, right? I keep saying that for a reason. Example 1, Mary received an 8% raise of her monthly salary. Go Mary. The amount of her raise was $48.16 per month. What was her monthly salary before the raise? Ooh, fun, right? What we need to do here is we need to realize what type of question this is. In this case, this is a figure out the fraction that equals the percent, or by context clues, what we've been doing. And then we need to solve for it, because what we're asking here is an 8% raise of 48.16 is what to the original, right? How do we solve this? Well, first we need to figure out what the answer should kind of look like, right? If we don't know where to go, we should at least try to estimate or try to take a top of the head approach. Okay, what should the answer look like? 8% raise is $48. So we're probably looking, obviously we're looking at a number larger than 48, right? Our answer should be larger than 48. How much larger should it be for a monthly salary? That's kind of tough to do in our head, right? 8% of what is 48? Well, I don't know, right? This is a question that maybe answering it in your head isn't the best approach because it's using all these weird numbers, like using change with percent, using, 16 cents and trying to figure out what 8% works with that. It sucks. Okay. Maybe that's not the best approach. Well, lucky for us, we have other methods here. Namely, this involves percents. Percent has a very strict definition, right? A percent is something over 100. In this case, 8 over 100. Sweet. So we know 8 over 100 is less than 100%. This numerator is a lot smaller than this denominator. So if we do a ratio, if we do an equivalent fraction, we got to think this number is this number in the numerator or the denominator, right? We have a skeleton to build here. If you want to talk about amount and base, you can. I never thought about that way, but the book's pushing that. So if you use the book, that's another way to look at it. What is your amount? What is your base? Where does this go? How does that work with the math? That's the idea here. If you watch this on YouTube, I suggest you pause the video, try to solve it for yourself, and then continue the video after that fact. If you're in the live stream like this, we'll kind of just go on, but I use these long talking sections here to let you jump ahead of me a little bit and check your own work. That's the idea, right? I'm trying to essentially teach now and teach in the future simultaneously. It's just the best way to teach math. So what goes where, right? We have a basic question here. We got a 4816. What do we do with it? Is it a numerator or is it a denominator? Is it a, I've got to erase that part too. Is it a amount or is it a base? Is it the top or is it the bottom? There we go, right? What they suggested to do, what Pearson's LLC suggested to do, was to rethink of the equation as a sentence that we've been discussing, and then plug it into your skeleton of equation. I imagine most of us don't need to do that approach because if you understand the skeleton of the equation, you can drop stuff in easily. And hey, look at this. This is what we had written before, right? Cool, we were doing it correctly. And we had set the skeleton up such that this guy here, the question was top or bottom. And as we discussed already, we noticed that this particular percentage equation, the 8 was the smaller number. Okay, so if we think about the question here, 4816 is probably going to be smaller than what you were making as a salary before then, right? That kind of makes sense. Hopefully your raise doesn't, hopefully if your raise is $48, you didn't double your salary. If you did, sweet Lord, you wouldn't make a lot of money, right? So again, we can look at this and we can say, oh, cool. This must be the numerator because it's small, just like this guy is. They're both small numbers. They're both in the numerator. The 8 is in the numerator expressly because it is 8%. So maybe that 48, which I also expect to be smaller than my answer, should also be in the numerator, right? This synchronicity going on here between these two works to my advantage. Now, once I have this basic equation here set up, my hard work is done. At this point, I just need to go about and solve the math of it. How do I solve the math of it? Well, that's the cross multiply to get it in a non-fraction, and then run through to the answer, as shown here. Your base is 602. They use equation method and portion method. These two are the exact same thing. Whichever one you prefer to write as is up to you. I think this method is going to be probably easier for most of you because, again, the idea of building that skeleton is very useful. If you really like this is the same thing as equals and 8 is the same thing as, if you prefer that method, I'm not stopping you from doing that. I'm just here to argue the portion method may be a bit smoother and it's more akin to what you probably learned in your previous math classes. And the point of this all is, hey, look at that. The answer is 602. That is a lot larger than 4816, which is what we expected. I don't know if I could have imagined a number on 600 in my head without doing a lot of thinking, because the wish man to look like approach wasn't very helpful for the situation, but we're doing pretty good. And I will say a monthly salary of $600 is, you need a new job at that point, right? That's not making a whole lot of money. But yeah, once you set up your skeleton equation, you're doing pretty good. So, solving markup problems. Markups is essentially the bread and butter of the proportionality and the percentages conversations. This is the, oh boy, I'm at the supermarket. I want to know which bag of chocolate is the better deal here. Should I get the big old strips of Hershey bars, or should I get that little Hershey's miniature mix-up bag? Which was going to give me the most chocolate for my money? I had this conversation with myself yesterday when I was at the store buying some chocolate. Come to find out, the miniatures actually save you a bit on money per ounce of chocolate. So there you go. Assuming you can get around and enjoy Crackle and Mr. Goodball. But who doesn't like Mr. Goodballs, right? They're truly the best. Anyways, I went off on a tangent. Some markup problems. Percents can be added in the base if the base is the same. These types of problems are also called markup problems, i.e., the markup being the 15% added to the original cost. I'm sure we're all well aware of what a markup is, but they're just trying to figure out, well, I guess I can do that too. They're just trying to put it in super mathy terms, right? So Mark is taking Peggy out to dinner. Good for Mark, good for Peggy. He has $66 to spend. It's a very interesting way to take a Peggy out to dinner. If he wants to tip the server 20%, how much can he afford to spend on the meal? I don't know if I want to go out to dinner with Mark. Mark seems like a very odd person to eat with. So what does this mean? Well, this paragraph here sucks to do the math on, right? I don't want this to be my math. I want to rewrite this equation in a way that is simple for mathematics. So let's break down this paragraph into something more feasible here. What is that 20%? Well, he has $66, so the end total of the entire conversation needs to add up to 66. He cannot exceed 66. If he spends more than $66, he didn't budget correctly, and obviously the date is a total disaster. We don't want Mark's date to be a disaster. We need to budget this correctly for him. This is why 66 is at the end of the equation. Equals 66. Everything to the left of the equal sign has to be 66. So what things add up to equal $66? Well, in this case, we have two things to talk about, right? We have the meal that Mark and Peggy are eating, and we have the tip that Mark wants to give the server at the end. Mark needs to know how much this meal costs in order that he can add 20% to it and get to his 66, right? That's the end goal here. What is the meal? If I add 20% to that number, I want to make sure I hit exactly 66 again, because Mark sounds like a wonderful dinner companion. Or to translate that into sentences, the meal plus the tip equals 66. Sweet. cost of meal N plus tip of 20% of the cost equals 66. This sentence sucks. That's bad math, right? So can we rephrase that in some way to make it a bit better? Well, what is the cost of the meal? The cost of the meal is the cost of the meal, right? So we're going to think about, okay, the meal costs exactly its percentage here. But I want to tip 20% on that percent, because what is you got to eat, right? You tip 15%, you tip 20%. That is based off your ticket. It's based off the end cost of the meal. So the meal itself includes that 20% on top of it. So you have, right? It's how tipping works, I guess. I'm not going to go over tipping. We all understand that. I don't need to explain that very much. But that's the idea behind the math. So we need to take this idea of paying for the meal and adding the tip, and then subtract out the cost of the tip before I get the meal in order to make sure that I can pay for the meal and the tip. Again, Mark does not sound like someone I want to have a meal with. This is way too much thinking when you go out to eat. Let me order what I want, Mark. Sweet Lord. So what does this all account for? Well, this accounts for about 120% of N equals the meal. You need to figure out what the meal's cost is so that when you add 20%, you still stay below your portion. Lucky for us, 120% is the same thing as saying 1.2. Now here, hooray, we finally land ourselves on an equation. We finally land ourselves on something that I can use my calculator, or if I'm really good at division, my head, and solve for. At this point, divide over the 1.2, and we land on a meal of $55. Mark and Peggy's meal needs to be split, including drinks and dessert, what have you. $55 in order for him to tip 20% and still land $66. Right? The math is super easy. Everything below the line here, everything below the line, you know how to do. That's not the point of this conversation, right? The point of this conversation is everything above the line. Setting up the math so you can solve it is what we're doing here. And some of these questions are just, wow, only a mathematician would think that's an appropriate way to go out to eat. But the point is, these should be difficult, so I can't begrudge them too much. Discount problems. Same thing, but in the opposite direction, right? Discount rates. Discount rates are how much you're taking off the list price. The sofa costs $500. I'm taking 30% off. The discount is the cost after I take off the discount. Right? Cool. We've all been shopping before. I don't think I need to begrudge where discount is too much. Let's use that in a question, though. Julie bought a leather sofa, good for her, that was on sale for 35% off its original price of $120. What was the discount and how much did Julie pay? Notice we have two question marks here. We have two different questions going on. I need to know what the discount was. I need to know how much Julie paid. Because just is 35% going to be within my budget? These are important questions to ask. So how do we solve that? Well, on the previous slide here, we find out that your discount is equal to your discount rate times your list price. If you know your discount rate, you know your list price, multiply those together, get your discount. So of these numbers up here, which one is the price? Which one is the discount? Well, your price is going to always have your money involved, right? This is your list price or original price, same thing. This is how much the sofa was before the sale. So we can drop that into our equation here and land on 120 as our list price. Our discount rates are always percentages. So you see a percentage, you have a discount rate percentage. I did that backwards, oh my gosh. Rate percentage. So the equation simply states, if we take our list price and we multiply by discount rate, we get our total discount. Because remember, 35 is 35% is 35 over 100. If I multiply that by 120, make that look like a 3, there we go. Multiply that by 1200, what am I doing? I'm multiplying straight across. I'm getting a number that is going to be smaller than 1200 because it's 1200 divided by 100, right? So my discount's going to be smaller than my list price, hence discount, right? Doing this simple math out, we get a discount of 420. What does that mean? That means you take the list price, subtract $420 from it, and you end up with the amount paid. The amount paid being $78. Julie bought a $1,200 sofa for a little under $800. Hey, not a bad deal, right? I'm sure, I don't know if that's a good price for the couch or not, but I hope Julie got her money's worth. Again, to stress it, the issue is not this. We all know how to do these equations. Our calculators do that for us. This is easy math. The problem here is building the equation, building the skeleton off of what remains of the paragraph. Cool. Approaching the end of the slides here, section 5.5, solving commission, percent or increase or decrease in interest problems. Not there. Again, we're just going over different variations of the same equations, right? That should look familiar to you. Different forms of percentage problems. Cool. Solving commission problems. The amount of money a person makes that is a percent of the value of the sales is called a commission. I sold $5,000. My commission is 10%. I made $500 off of those sales on top of everything else, right? It is calculated by multiplying the percentage or the commission rate by the value of the sales. That should look eerily familiar to us, right? Because that's a lot like discount. That's the exact same equation, just we have a different place where the numbers come from. Example again, this math looks super easy because it is, right? Example, being a salesperson has a commission rate of 18.5%. He sells $43,250 worth of goods, probably a car, I assume at that point. What is his commission? Well, you say what is rate means percent. Rate means percent. If you see a rate, you probably have a percent. So 1850 is your commission rate. It drops into that part of the equation. The only other number available, it says here, sells $43,250 worth of goods. So sales, stuff sticks in very well, right? Convert 18.5% over to a decimal because you never use percents in math. Percent is a way to represent something. Convert it over, super important, and then punch that in. There you go. Good old salesperson here made $8,000 off of his sales. Seems nice. I'm proud of him. Right? Again, I'll go over the stuff in more depth if it's required. Ask in the comments or ask now. But if it's something as straightforward as this, I don't think I need to belabor the point. Once you know what the equation looks like, and again, I'm gonna say it here. If you don't know this basic component, you may run into issues. Look at the question, figure out what equation is useful, and then once you know the equation, write this actual sentence down if you need to, right? If you know the equation, it's easy to drop in the individual numbers to replace the words. That's super beneficial. That might just be what you need to do. Not everyone can immediately jump here. Sometimes you need to go through those first two steps, hence why they're there as steps in the first place. There we go. More problems, solving increase and decrease problems. We sometimes need to find the percent by which a number increases or decreases. Again, lucky for us, we have a nice equation here. Percent of increase is the amount of increase over the original amount. So that is a percent, because if we go back, right, we go back to our original skeleton we talked about before. We said percent number over 100, it's supposed to be 100, equals what? Amount over base. Doesn't that look familiar? Your percent increase is your amount over base. This equation here is the exact equation we were doing before. Just we're changing the phrasing a little bit to better fit into the word problems that we have. The cost of a certain car increased from $16,000 last year to $17,280 this year. What was the percent increase amount? Okay, so what do I need to do? I need to look at my equation. Percent increase equals amount of increase over original amount. Find what I know, solve for what I don't. Do I know what? Well, actually, let me stay in mouse. There we go. What do I know here? Well, I've got two different numbers, and I have a question marks next to percent. So here is my equation. My percent is my unknown. I don't know the percent, so this will be my variable. And then my original amount, well, that comes from the sentence. We need to read the sentence to figure out which one is the original here. The cost of a certain car increased from that last year to something else. What was my original? Where did I start? I started at my from. From is the important word in this sentence. From says this number right here is the old number, and this number right here is the new number. Fantastic. The original looks a lot like old. So I know the number on the denominator, this particular equation, needs to be my old number. So does that mean the top number is my new number? Well, slow down now, right? Because we notice here in the equation, amount of increase is not, this does not say new amount, right? It says amount of increase. So we need to think, what is amount of increase? What does that mean? How much it increased, how much it grew. To know how much it grew, we need to do a separate equation shown up here at the top to figure out that amount of increase, or how much things raised. We've been doing these sort of problems throughout, these these nested questions that reside inside the actual question. In this case, subtract them out, 1280. That is the amount of increase that's shown down below. And now we have a very simple math problem, right? Fill in what we have, get what we want. What was it, 1600? 1280 over 600 equals x. All numbers on one side, all letters on the other side. That's a very simple equation. Solve this, and we have it out. So what is this 0.08? Well, we said we wanted a percent as our answer, so we need to realize I'm going to jump that decimal place over twice, land on 8%. Voila, we have a answer. Sweet. The cost of the car jumped 8% from last year to this year. Decrease, I'm not going to go over this in too much in depth, right? This is the exact same conversation, except instead of adding things, we subtract things. Patrick weighed 285 2 years ago. After dieting, he reduced his weight to 171. Good job, Patrick. What was the percent of decrease in his weight? Exact same equation, right? Percent decrease, this is a percent we're going to have at the end of all this. And then original amount is our old amount, how much he weighed when this started. 2 years ago, that's old. So our old number is what he weighed 2 years ago. Amount of decrease, this is a separate equation that we need to solve for. Because the amount of decrease, again, we got to use English here. Amount of decrease says a difference between things. This is a difference. solve our old equation, get a numerator, and then we have a mathematical equation that is in the form of number equals variable, numbers on one side, variable on the other side. Hey, solve it, right? And then at the end of the day, we need to remember that our answer needs to be in percent. This is not a percent. So the correct answer would be to convert that into a percentage, which would be 40%, right? Good old Patrick lost 40% of his weight. That's a lot of weight, Patrick. Good on you. Now we can get into more complicated stuff. Simple interest problems. Interest rate is a big part of math. If you take any math classes going forward, you're going to dive deep into this stuff, especially if you take a math for the real world sort of class. It gets much more complicated than this, but interest rates are a good introduction to the depth that this subject can go. So, interest is money paid for the use of money. Fun, right? The principal is the term that we use to describe the amount deposited or borrowed. You start with your principal, that is your basic amount. And then you have an interest rate that is, in this example, per year, but it varies. And that rate, right? Rate means percent. Interest rates tie in, as said here, to some amount of time. In these examples, we're going to simplify things and say the interest rate is in years. For the sake of conversation, interest rates could be months, interest rates could be days, interest rates could be compounded continuously. That's a subject for another time, however. So your interest is your money, which means you have usually a dollars and cents conversation. This is an integer. And then you have a rate, which is a percent. And then you have a principal, which is a usually smaller integer. Cool. When we start these conversations, we got this big old equation here, 4 different variables, right? Well, and then time is in years. When we start this conversation, if we think, okay, I know my sorry, I have that backwards. My bad. I don't know if you corrected me on that. Your principal is your larger, not your smaller. Hopefully. Hopefully your principal is larger than your interest. There we go. I hate writing with my mouse like this. So when we get to these questions, we have all 4 of these variables, but we realize what they're going to look like beforehand. If we see a number that ends in years, we know that is a time. If we see a percentage, we know that is a rate. If we see a big number, that's probably a principal. If we see a small number, that's probably a interest, right? If need be, you can write your variables on the side. Interest equals 30. Principal equals 50,000, something like that, right? Rate equals 5%. These steps, however, whatever step you do to solve the problems, I'm going to encourage you to, first and foremost, simply know what's going on here. A lot of stuff going on. We can bring it all together, make something nice and easy for us. Here's an example here. Find the simple interest on a loan of $3,600 borrowed at 6% for 8 years. So we have 3 different numbers, 1 unknown. The question is, what of these numbers is I, P, R, and T, right? I is your interest. This is going to be usually your smaller number. If it's your larger number, then you either almost paid off your loan, or you have to have paid off your loan, right? Your interest can't be larger than your loan. Your principal tends to be your larger number. Your rate is your percentage, and your time is going to be your years. Cool. So we need to look at this sentence, figure out what goes where. 6%, hey, that's a rate, right? And then, of course, you don't use percentages in math, so you convert it over to a decimal. Year, that's a years, right? So that goes in T, that goes right there. Then we need to figure out which of these two is going to be a smaller number. Well, I know interest is the smaller number, and interest is the unknown because it's not given to us. It said right here, find the interest. And 3,600, that means 3,600 is my larger number, and my larger number is my P. So that drops there. This sort of, you don't have to write all that stuff down necessarily, but it's good to run through this stuff in your head. Notice, hey, I have bigger numbers here, smaller numbers here, this goes here, that goes there. Writing out this equation to start out and then filling it in later can save you a lot of hassle. Right? Take 3 steps if needed. And then once you get here, this equation is very easy to solve. Good for us. Your interest rate is 1,728. Cool. That's the basics of percentages. It is not, I mean, the complication, as I said already, is not coming from the math side of things. The complication is coming from converting the sentence, right? The complication is coming from how do I take all these words and turn them into a math problem. Things that are going to trip you up when you do this stuff. First of all, not taking your time. That happens to all of us all the time, right? Jumping the gun, not writing down the skeleton of a sentence and then filling in the numbers, that's going to cause you to make a mistake because maybe you're going to see this number and think, oh, that must be XYZ thing that it's not. I'm going to give you questions that you don't solve for I. Your unknown will actually be the principal. This will be the unknown. And so if the principal is the unknown, you need to realize, and you will by writing out your question, that if your interest was 300, your principal times, 6% over 10 years. If that's your equation, you need to realize, hey, I need to do some stuff. I need to move this guy over here. I need to move this guy over here. So I have numbers on one side, numbers on the other side before I solve it. If this is what your equation is supposed to look like, but you confuse P and I, and instead you draw it something like this, with that being the 300, you're doing it wrong. Take your time, draw out your equation. Would you get good at this stuff? Sure, do whatever you want. But until you don't make the mistakes, by definition, you're going to make mistakes, right? That's the big thing, is draw the skeleton is going to be super useful for this stuff. Because that's cake, right? That's absolute cake. These candles, cake. That's a terrible candles. The other thing, beyond the skeleton, you're also going to need to translate your sentence correctly. Usually the two will connect together very well for you. If you draw the skeleton, the sentence will fall in place. If you don't draw the skeleton, the sentence sometimes can be a bit of a hassle. If you get stuck, break it down to smaller and smaller and smaller sections. Write down, okay, 3,600. That's not my interest, so this is going to be big. Write this stuff down. I'm telling you, it's going to be useful to you. I guess I'll probably end the recording here, and then I'll open up to any questions you have, unless you really want to ask a question in the recording. That's up to you. But if it's cool with you guys, I'll stop the recording. We can go over things that require more in depth. As I said, the YouTube comment section is another place you can go for questions. I check that minimum once a week, usually once every other day. And yeah, that's what we got for percentages. Cool. So I'll stop recording now. Thanks for watching, anyone on YouTube, and take care.